velocity. So in order to find the angular velocity, the formula is angular velocity will be equal to velocity divided by length of the link. So angular velocity is found out for link RQ, that is 1.83 radian per second. Similarly for RS, angular velocity of RS is equal to velocity of the link RS divided by length of the link RS. So you will get the value of angular velocity of RS as 3.91 radian per second. So this is part 1 of this problem. Today we are going to see about the part 2 of this problem. That is, we are going to calculate the acceleration component. That is, acceleration diagram we are going to construct. In order to construct the acceleration, first of all you need to find out the values. So in order to find out the value for acceleration diagram, acceleration, the formula is acceleration of the link PQ will be velocity of the link PQ divided by length of the link PQ. So we already know the velocity of the link PQ is 0.625 meters per second square, the whole square, divided by length of the link PQ. Length of the link PQ is 0. That is 0. What you have to do is, so if you divide it by 1000, 62.5 divided by 1000. So you will obtain 0.0625. So 0.0625. Okay. So this is how we have to find the acceleration of the each link. So I have already found out the acceleration component. So let us see the values. So acceleration of PQ is 6.25 meters per second square. Similarly, acceleration of the link QR will be equal to velocity of the link QR divided by length of the link QR. That is 0.32 the whole square divided by length of the link is 0.175. If you calculate, you will get the value as 0.634 meters per second square. Similarly, acceleration of the link OS, that is velocity of the link OS the whole square divided by length of the link OS, that is 0.44 the whole square divided by 0.1125. So you will get the value as 1.613 meters per second square. So we have obtained the acceleration values for all the links in the velocity diagram. So these are all radial components. The moving components are radial components. So there is one more component, tangential component. Let us see how the radial component, tangential component are drawn in the acceleration diagram. So while starting the diagram, you should know the values first, and then you have to think in what scale we can draw this diagram. So you can see here, the first link is 6.2, the second link is 0.6, and the third link is 1.6. So these values I am taking the scale value as 1 centimeter equal to 1 meters per second square. So this is what my scale for acceleration diagram. So again, we know that the acceleration diagram, it is a, how will you draw acceleration diagram? The acceleration diagram can be drawn by constructing perpendicular line to the velocity diagram. So what is the first thing here? PS. So PS is already fixed. So what I am doing is I am marking a point somewhere in the space. Okay. So then for this line I am going to construct a perpendicular line. So what length I have to draw? I have obtained here as 6.25 meters per second square, which means I have to draw according to my scale. It is 6.25 centimeter. So this line I am taking perpendicular line for this line. So perpendicular line for this line. So this is how you have to move your scale in your notebook. Yes, I have obtained this. I have transformed this line. So I am marking this line approximately a straight line, that is a 90-degree line for the length PQ. Yes. The length of the line is from this point to this point it is 6.25 centimeter. So I am drawing a line for 6.25 centimeter. Yes. So this is P comma S and this line is Q. So the next point here is from this point, the next line that is from Q to R, that is 0.6 centimeter according to my scale. So for the length QR, in the velocity diagram, you have to construct a perpendicular line for this diagram like this. QR line. I am taking a perpendicular line like this. Yes. This line is perpendicular to the length QR in the velocity diagram, and the length of the line is 0.6 centimeter according to my scale value. So this line is acceleration radial component for QR. And the next thing what I have to do is, once if you draw a radial component, you have to draw a tangential component. So how will you draw a tangential component? A tangential component can be drawn